Hello everyone, I'm Hal and I will be teaching massive data mining and learning in spring 2021. And in this video, I'll give a brief introduction to tell you what you're going to learn in this course. So, what is data mining? In short, data mining means knowledge discovered from data. And to do this, you will need massive data, massive storage, and massive computing power. To give you some idea of how massive this is, it's estimated that there's about 30 billion pieces of content shared on Facebook every month. So in this age of big data, this data actually contains a lot of value and knowledge. However, in order to extract this knowledge from the data, this data needs to be stored. And this is already covered in the course massive data storage and retrieval. The data also needs to be managed, and this is already covered in the course database management. Last but not least, this data needs to be analyzed, which will be the focus of this course, massive data mining and learning. Now, data mining, basically, it tries to discover patterns and models that are valid, useful, unexpected, and understandable. And valid means that this model needs to work on new data that the model hasn't seen before. And useful means that it should help us to learn something new from the data. Unexpected means that it needs to be non-obvious to us. And understandable meaning the human should be able to interpret the pattern and explain the pattern to their friends, for example. And there's this one term, data science, which is related to data mining. And you can think of data science as data mining with some emphasis on predictive analytics. And if you think about traditional science, what they do is that science will analyze, they manually analyze a lot of data, process them, and then develop some physical law, and then will try to predict the future using this physical law. One example is Tycho Brahe, who is a famous Denmark astronomer who's very good at astral observation. He observes and records a lot of data about how planets circle around the sun. And then another astronomer, Kepler, analyzed his data and discovered the Kepler's law of the planets. And then he used this law to make predictions of how planets will move around. This is probably one of the oldest examples of data science with some manual operation. But nowadays, we have massive data. For example, the search log engine, e-commerce transactions, and social network data. It's impossible to manually analyze this data and derive conclusions from the data. So we have to rely on massive computing facilities and develop advanced algorithms to analyze the data and make predictions. And these advanced algorithms will come from the fields like machine learning, data mining, etc., etc. And for those of you who will be on the market soon, good news is there has been a huge demand for data science these days. For example, if you look at the job listings, there has been a growth of about 37% in terms of job listings since 2019. And about 67% of the companies are trying to expand their data science team. And if you look at this plot here, you can see that in recent years, there were about 3 times more postings than job searches in terms of data scientists. And this means there's a huge shortage of data scientists on the market. So we have basically 2 categories of data mining tasks. We have descriptive tasks, which try to find human interpretable patterns that describe the data. For example, clustering. Usually we want to group the data into clusters so that we can understand them better. And we have predictive tasks, which try to use some variables to predict unknown or future values of other variables. For example, recommender systems and computational advertising. And more concretely, recommender systems, they try to predict the preferences of the users given some past history of the users. And computational advertising basically try to do similar stuff. It's just that what they're trying to predict is basically the clicks of the users. And this course, CS550, basically overlaps with machine learning and statistics, artificial intelligence, databases, but we will put more stress on the scalability, which is related to big data. And we also put more stress on algorithms, computing architectures, and automation for handling large data. In this course, we will learn to mine different types of data. For example, we will handle data that is high dimensional, which is related to dimensionality reduction. We will handle data that is a graph, which related to social and web link graph analytics. We will also handle data that is infinite or never ending, and this is related to streaming data processing. And we will also handle, of course, data that is labeled or unlabeled. And these correspond to supervised learning and unsupervised learning. We will learn to use different models of computation, including MapReduce, streaming and online algorithms, and single machine in memory. We will also learn to solve different real-world problems, including recommender systems. For example, an Amazon recommender system will try to recommend products to users given the user's purchase history. And this is related to dimensionality reduction, latent vector models, collaborative filtering, and of course, deep learning. And we will also cover market basket analysis, spam detection, and social network analysis. We will learn various tools. For example, we will learn singular value decomposition, latent vector models, and community analysis. And this is all built on linear algebra. We will also learn stochastic gradient descent, SGD, which is a very popular optimization method, especially for learning neural networks. We will also talk about frequent item sets, which is naturally done by dynamic programming. We'll learn locality sensitive hashing and Bloom filters. And this is belonging to the category of hashing algorithm. So this is how it all fits together. We will learn to handle various types of data, high dimensional, graph, and infinite data. We will talk about machine learning and different kind of applications. So about this course, the most important thing is that it's going to be asynchronous remote. So there will be no synchronous or real-time virtual lectures. These will be replaced by posted videos on Canvas. And of course, there will be office hours that are synchronous via Zoom. And you can also post questions on the discussion forums on Canvas. For the prerequisite, one of them would be fundamental algorithms, which is covered in CS 512 and 513. And these are basically related to linear algebra and basic data structures. And also you are going to need some basic probability theory, including moments, typical distributions like Gaussian distributions, and maximum likelihood estimate. And for the programming language, you can choose whichever programming language you're familiar with, but C++, Java, and Python will be particularly useful. And in this course, we'll provide some background on the prerequisite, but overall, the course is going to be fast-paced. For the course logistics, you can check the website, which is recently set up. And if you haven't, please join our Canvas homepage. And all the lectures, videos, slides, homework, solutions, readings will be posted on Canvas. We will use mining of massive datasets as our textbook, and this will be freely online. So you can download them. For communication, students are encouraged to pose questions and actively participate in discussions on the Canvas QA portal. And please use Canvas for all technical questions and public communications with the core staff. And for private questions, you can always email me or to the TA, and we will post course announcements on the course website and on Canvas. So make sure you check it regularly. For the workload, we will have 5 homework, and one of them, homework 0, is going to be a exercise homework, so it's not going to be graded. Homework 1 to 4 is going to take 12.5 points each, and these assignments will take a lot of time, so start early, okay? Homework assignment will be posted on Fridays, and you're going to have 2 weeks to finish them and submit them on Canvas. For the midterm, it will take up 15%. And to accommodate students in various time zones and the COVID situation, the tentative plan now is to have a midterm that's 24-hour and take-home exam. And the final project, you're expected to complete this final project as a team of at most 4 students. You can choose between an assigned project or a self-proposed project. And you will need to provide a 10 to 15-minute presentation. It's going to be fun and hard work. For additional details, you can check our course website in here. Thank you.